Welcome to Rubber Duck Engineering. Oh man, I'm blowing it already, aren't I? I'm Adam. Hi, Eric.
Hi, Adam.
So this week we're going to continue our adventure in Wren. So we are going to try to undo our hack that we had last week, where we secretly inserted the print function into the method dispatcher, and we've actually tried to dispatch the print method correctly to an actual function. Eric tells me this is possible. I have no idea.
I believe this is possible. I believe we have the technology. It might crash. Well, who knows what we're gonna try. And then I think since hopefully that will take about 2 minutes, we will continue our adventures from there and maybe making functions work.
I don't know. I whenever I think something's going to take 2 minutes in writing software, it always takes much longer than that.
Well, last week we had maybe moved to like sticks and stones. I've now moved to like rocks.
Oh, we can bang rocks against each other and make sparks.
Yeah, I got sparks. Maybe rocks is wrong. Maybe we're Bronze Age. I don't know. There's been significant technological evolution in the code base.
I always use the phrase stone knives and bear skins. I don't know where that comes from.
I don't know. But shall we?
Yeah, to the code machine.
To the code machine. Oh no.
Oh no, there's no code machine.
The code machine.
Oh,
okay.
I thought the code machine was broken.
No, the code machine's here. One of the things I did was I wrote down all sorts of things to do in the README, and I stopped. Oh wow! I mean, I could give you a tour, but let's attack what we were going to attack. So last time we have this terrible, awful hack in our method dispatch. If I look for system in the VM file, you will find what?
For calling a function, if by chance the function is called print, then mysteriously do this.
And we call our magical print function. The way this should work, if we look at the way Wren C wires it up, is on the system class object, on its class object.
We have a comment from Frank. Hi, Frank.
Oh, hi, Frank. Nice to see you. On the systems class object, which I think is like the system meta class or something like that. This is how you do static functions. You then add the thing. So in the actual Wren, they don't have the print function exposed. They have a write string function, and it's due to details of that from within primitive functions you cannot call back into Wren. And so in order to have toString implemented correctly, there's a big comment somewhere in the code about this. In order to have toString implemented correctly, they do all the toStringing up in Wren, actual Wren code. You may or may not have seen, and this is one of the things that I've added since we last talked, but wrencore.wren. This is a function or a file that is loaded into all running Wren code. So the first thing the VM does when it wakes up is it loads this file.
And the system class is in here?
The system class is in here. System class is
I see.
partially defined in here.
I see. It just calls through to write string or whatever.
Correct. So print this thing, print object.
Oh, Frank is asking us to increase the font size.
Oh. I can try.
I think it's kind of like Command Shift plus.
Command Shift plus? Oh my goodness. So much font. So much size. We'll see how this rolls. I don't have a lot of pixels, but I recognize if one is viewing this from a phone, it could be really hard to see. So like print object, it actually just calls write string.
I see. That makes sense.
And apropos of nothing, we were talking about crashers in the Wren C code. I've never actually compiled. You're welcome. I've never actually compiled Wren C. I've only read the code and then transcribed it into Rust. So someday I should actually compile Wren C. But I have found on numerous occasions where I think the Wren C code will crash. One is, for example, is if you ever call this write string code or something that is not a string, I believe it will crash.
Is it exposed, or does the underbar mean that it's private in some way?
I don't actually know, because I've never compiled Wren C, so I can't try it. Actually, there is I don't have a web browser handy. Actually, if I hide this for just a second,
Oh, is that like a web, like dartpad kind of equivalent for Wren?
there is a dartpad equivalent of Wren.
I know in Dart the underscore controls the visibility, so it might have.
Wren has underscores. Let's see, Wren online. Oh my goodness, what is it? No, I don't want online kitchen planners.
So that's a different Wren.
That's a totally different Wren.
Oh, there was a try it button on the right. Is that what you were looking for?
Yeah, there's a try it button. Yes, try it. This thing. Oh, interesting. I've seen it embedded elsewhere. But I think if you do write string, is that what it was?
Right string, yeah.
So what happens if you just do write? Oh, well, these don't have
new lines. There we go.
Oh, hello. Okay.
Oh, Frank asked you a question in the chat.
Eric, how many
Erica's a chat.
home? I have 3, I think.
Are they all visible in frame if we very carefully study your camera?
Probably all visible in frame. I also have a thing that looks kind of like a dash, but is not a dash. It's like a tie-dyed owl from like a.
There's an imposter dash.
It's an imposter dash.
One of these episodes, we will substitute a regular dash with an imposter dash.
Okay, so write string does work. So I suspect like it's going to be like a JavaScript exception because this is in WASM here. But if we do write string and we pass like 1.0, I have no idea.
I don't know what happens when like WASM code crashes. Does it produce a stack trace in your JavaScript console?
I have no idea. Anyways, because it just blindly casts it to a string.
That's terrifying.
Anyway, there's a whole bunch of terrifying C code in this. Anyways, what were we doing? We were doing our 2-minute fix.
Yes, this is why everything takes more than 2 minutes. But the idea is, but you're just going to install like a print function instead of this write string function.
Yeah. So I think if I basically just take this thing over to my version of core, and I use our fancy version of this primitive macro, and I do core.string. That's the core string class, and then I want class object on that.
Do you mean system?
I think print. What did I say?
Do you mean the system class?
Oh, did I do? Oh, yeah. System is actually probably not on here. Yeah, it isn't. So I'm gonna have to do this instead. The thing to help to go look up the class for us. System, and then this is prim system print, and I suspect that the signature is not quite right. Because prim system print was like the first primitive ever made. Did that
no errors. So that's either a good sign or a bad sign.
Holy bananas. Okay. So if we just remove this, unused import. Yeah, you better believe it.
You're gonna run all the tests? That's ambitious. I would have just run it like a.
They don't take any time. Okay, it's clearly failing. Because otherwise it would be passing for by now. Ergo, run, test, bring up. Not found. Print in system meta class.
Do you need to install it on the meta class? I guess you got the class object from the.
it should be this. The class object should be the system meta class. Let's see. Let's see what we actually install this thing on. Oh, yeah.
Actually, you installed it on the system class.
I installed it on the class.
It's mad about your
no method class object found instructor. Oh, we gotta borrow, because this thing actually returns an RC, something like that. Oh, is it borrow? What do we need? Borrow mut. So we need. Oh,
I think you may want to just pull it out into a local variable. I'm not sure if your macro is.
What is this thing returning? It's returning a handle, which is what we want. So handle is itself a type alias. We can try pulling this out into a thing. Let system. It's nothing. It's this thing. What does class object return? Oh, it returns an option. That was our actual problem. So we need to call unwrap.
Probably before, right? Before you call class object.
I think it's the class object. No method class object for struct RC in the current scope. Oh, this is actually where you do need to borrow. It's probably going to say it's a move. Oh, no, there we go.
Oh, I see. I need to save.
It could save. Maybe I turned off the like. There we go.
1, 2, 3. Oh, whoa! It printed. Yay! Yeah. Good work.
So I think with our current technology, we can remove our hack in 1 line of code. I don't. Maybe that wasn't quite 2 minutes, but this number's not going up quite as fast as I expected to.
Oh, I see. It's flashing. It's flashing a green number on there.
Yeah. The PowerShell. So they're doing this funny curses thing or whatever, where they're trying to put it at the bottom. That seems about right. That seems 2 less than I would expect.
Do you have like a golden file or something you check these against?
Yep.
Oh, num and string have them.
Really?
Apparently.
Oh, you know what?
Because you were just stealing the print method on everything.
Yeah. So what changed about passes? So global and syntax are now gone. Okay. This is all probably good. These are just junk changes. If we do, this is Windows fighting us.
It's like line endings or something.
Yeah, it's because we touched the files and not found. Missing expected output arg. Okay.
I think these are just places where you were randomly grabbing the print method and doing something reasonable, whereas now it's correctly determining that you don't have it.
Yep. So we fixed some tests. I mean, fixed. This is the current state of things where many things pass when they shouldn't pass. It was good. And we indented this. Yeah. Remove the system.print hack. RD, what are we, number 53?
Something like that.
System.print is now correctly defined on the system meta class. Plus a static. I would really like GitHub Desktop. At least on Windows, where the command line is more of a pain. Or I'm just not, my fingers are not used to PowerShell yet. Okay, so I think we could move on to bigger and brighter adventures.
Yeah, what's next?
Well, if we look at our README, one of the technologies that I built since is this common test errors. there's this util to fix thing, which greps through all of the test results and then cleans up the lines a little bit to remove things that make them different, needlessly different, like line numbers, and then sorts them into these buckets. So the number one error that we hit is this: we're expecting something left square bracket, and this is just telling us that we haven't implemented list literal syntax, and so it sees a left square bracket and it just gets all confused.
Is that as opposed to like indexing into an array with a bracket?
Yeah, that one it knows how to treat as a method call. And I think it sees one of those and it tries to treat it as a method call, and like it gets confused. Like it runs into a comma or whatever.
I see, but you don't have objects or arrays yet, so that might be a little bit ambitious.
I was just sort of showing you this tech, but yeah, no, we definitely can't do that. This is dealing with construction. We don't have objects. This is fibers, which we don't have implemented yet. This is imports. What's this one? Left curly brace. This one I would expect it to have gone way down, because one of the things I did just before the show is I finished a patch that I've been working on the last few nights, which added block argument parsing, which is how you do functions in Wren. So like, here's an example of doing a function. You call the fn.new and you pass it a block argument. That's how you create a function.
Crazy. That's some crazy syntax right there.
It is, and what's even crazier is that the behavior of this is different when there's a new line between these versus not.
What's the difference?
I think this one's
like expression oriented, and the other one is like statement oriented or something.
It changes the return somehow. It changes the return behavior, I think.
Okay.
I don't remember why, but I haven't implemented the fancy returning for this. So I think there's a chance that we could maybe make functions execute. That does seem a little ambitious for RDE. We could do some logical operators. Those are pretty straightforward.
Yeah,
we have static functions now. What do you say?
Let's do a logical operator. That sounds like fun.
All right. So that's more of, if you look at how Wren does it, there's a whole bunch of these, which until a couple days ago, I didn't have this like primitive fanciness. So if you look at our core, I learned how to do this.
I see. So we could do like bitwise and bitwise or. I saw them in the other.
This. Right. So it should be very straightforward to add bitwise and bitwise or all that stuff.
Okay. I'd love to see that. That sounds super interesting to me.
Sure. So the way I often do this is I just grab the C code. I don't know if we need to do all of these, but like that we want to do. And these are just infixes. So you can basically just do the same thing. So this is the name of the function. This is the Rust equivalent trait. And this is the return value.
Oh, wait, someone said hello from Peru.
Oh, hi from Peru.
Welcome to the show.
Yeah, welcome to the show. Cerbero Dev. Reminds me of Cerberus. Kerberos or whatever. Okay, so the question is...
So you're looking for like a Rust equivalent trait for bitwise and?
Exactly.
That's neat. You generate all the code, like you just defer to the Rust implementation. That's pretty cool.
So the question is, what is the Rust name of these things? They almost all have names. These things. So like bit and.
Okay.
So this is then, so to do bitwise and, we can just comment these out, is what we're going to call it. We're going to call it num bitwise and. I don't know.
Okay.
This is, well, what's the call? Like the bit and for Rust.
I see.
And. is bit and it returns. It returns a number.
Yeah. Can we look at this macro, this infix num op? Because it seems pretty magical based on what you just said.
Yes. It's not actually that magical. It was magical to write. I had to call in help. But really, like there isn't even very much macro stuff in here. It's just the function. It just defines the function with its name. What'd you say?
I see. I understand. It converts into a num and then applies the method.
Yeah, like none of this is macro stuff. Whoops. The macro stuff has these dollar signs around it, right? So we're declaring what the macro parameters are. So like we have a func parameter that's an identity, or an identifier rather. We have a method parameter, it's an identifier. We have a return type that's an identifier. There's some magic here that I don't fully understand, but like, so here we use the func to give it a name. Here we use the return type to explain which kind of value we're making and what method are we calling on this num. That's all. We could clearly make fancier things, but this was enough to get this to be nice and quick.
That's cool. There's a comment from Frank you might want to project.
Oh. ServoDev and I are from Flutter Peru. Hi from Flutter Peru. I have never been to Peru.
Can I ask a dumb question? What is Flutter Peru?
I think it's a Flutter meetup in Peru.
Oh, cool.
I know there's like Flutter Egypt and Flutter Germany and Flutter Spain, and I'm sure I'm not getting these all right, but there's like Flutter groups all over the world. This is from ops bitand. I think I imported all of the ops. I did. So why does it think bitand doesn't exist? Oh,
numbers are floating point. You do have separate integers and.
You don't. So I'll have to cast it to an integer to deal with this.
I see. Frank says it's a Flutter community. That's cool. That's awesome.
Yeah. Well, hello to Flutter Peru. Despite me wearing a Flutter shirt today, we're not actually doing Flutter tonight. We're doing silly Rust stuff.
So do you think we need like another version of this that's like try into int instead of try into num?
I mean,
how does it work in Wren? Like, are floating point and integers separate types, or they're just the bitwise operator?
Same type, but that's a good question. Like, what does this do?
I know this is a sore point in JavaScript where like all of the numerics are all floating point, except you need to do a lot of bitwise operations, and it gets kind of gnarly.
Okay, what is it doing? Find num bitwise. So here's the C macros, right?
I see. So it casts it to a U32. That makes sense. I mean, you could do something similar, right?
So what is this doing?
It's basically truncating it. Like it's taking a floor.
Mm-hmm.
It's like a C-style cast, right, from a float into a U32, then doing the numerics, and then going back to float.
Just making sure it's not a reinterpret cast was really what I was. So
I mean, it's C, so it's the only option is a static cast for numeric primitive.
Okay. I mean, this is straightforward to write. So we would just do the same thing, basically. We would go back to our, we'd go and we'd copy this one. And we would name it bitwise numop or something like that.
Mm-hmm.
And then we would.
So now we have to get fancy about how to get from Rust, from a float to U32 in Rust. Yeah, I think that will panic or something. Like, you want to take, I bet there's like a floor operator.
Oh, probably.
Float. Dude.
Well, if I remember correctly, lets are not happy in macros.
Yeah, I never really understood what the as operator does in Rust. Maybe this is a good time to learn since I use it all the time.
I don't really know what it does either. Let's just see if I did this right. This isn't quite right though. Oh, okay, no, this is right. But then I have to take this back to as F64. I bet this is all yellow because it's not being used. Expect that. Now it's mad at me. Oh, I'm letting inside a return.
Casting from a float to an integer will round the float towards 0, producing a saturating cast. So as is what you want. This looks like very similar to the C style.
Function never used. Yeah, okay. But
floats that are too big will turn into the largest possible integer. Floats that are too small become the smallest possible integer, and nan becomes 0.
So this is bit 4, I presume, and this is bit X4. I'm just imagining this is probably. No idea. Those are correct. Looks like I guessed correct for a couple of them.
Or the analyzer just hasn't caught it.
Yeah, let's find out what shift left and shift right are in Rust traits. There's a question: does Rust left shift shoal? Oh, that's the trait, though.
That's the trait that we have to figure out what the function's called.
Yeah. And there's like some languages. I remember Solidity had this. They like had a different or Ethereum.
A wrapping one.
Yeah.
I mean,
Rust in Spanish. Oh, really? Cerebro is Rust in Spanish? That's cool. And very appropriate for the evening. So I think that's it. Okay, we're just done. We did some magic, right? And well, that we've defined them. We now have to add them. I just deleted our examples. Go down here.
I find the sort of string declaration of the argument passing sort of fascinating. I'm always amazed, like at the unreasonable effectiveness of strings in these kind of systems. Like you can imagine a whole exploded data structure that's like, okay, what is the name of the method? How many arguments does it take? But it's just fascinating that it's packed into a string like this.
I think it's pretty common for symbols.
Well, Java has this too, right? It has some very elaborate syntax for explaining all the types of all the arguments and all that kind of stuff.
XOR, is shift left. Part of the reason why I never did any of these things, because you can see it didn't take very much time, is that I just didn't have the tech to do them. Like last week, if we had tried to write out these primitives, we'd be writing 5 lines for each primitive.
Mm-hmm.
But now with these macro tech, that was no time at all.
I feel like if you pick the identifiers exactly correctly, it could be even shorter, where you somehow name the function and based on the Rust trait in such a way that it was all 2 lines of code or something. Yeah,
these are all matching the are mostly matching, at least ones up here like plus and minus are matching what the C run Rust did or C Wren did, but they don't need to. This could just be num add, and then exactly the magic that you're referring to could work.
Yeah, there's always a trade-off of making things super magical, and then you don't really understand how it works anymore. But at least this seems very reasonable with what you've got here.
So assuming we didn't make any typos,
do you think more tests will pass?
Yeah, I doubt these are used in very many tests, so we probably get a test or 2, but I wouldn't expect a lot of tests. There's probably 8 tests that does this.
In that scenario, do you add a test yourself to demonstrate the progress, or?
That was the idea behind adding my own test directory. My own test directory has been more used for. I'm surprised to see so few. Maybe I'm just used to. So the tests run way faster on Mac. I don't know whether that's Rust. I think it's actually Python, or more likely the PowerShell. I think the terminal
maybe
way faster.
maybe HAL 9000 is here today. It's a party.
Oh
Welcome,
my
everyone.
goodness! Welcome, maybe Hal. Haven't seen you in forever.
Oh, 5 more passed, right? It was 150 before.
Is that
wasn't it?
True? So we can now see. We can see, for one, we now have more number required.
Does that mean we got farther into something and it errored out in a different place?
Like number required false. This feels like a loop.
Oh, I see.
So the way that loops work in Wren is you call this iterate value. The loop calls two things. In fact, the Wren folks have a really good description of this. Wren loop. Wren language 4. So like, where's loop? Maybe it's in control flow. Yeah, they do a nice job here, sort of explaining. Oh, well, I thought they did. Anyways,
That's always an iterator.
Right here.
Oh, so I see.
This is what a for loop
turns into. I see.
And so it calls iterate on the this iter thing, which is like your context object for your sequence or whatever, and then from that it then asks for the value that it's trying to give out. But this
and null is like falsy, or will break you out of the loop or something.
Oh, nothing is false. There's very few things. I think it's null, and so the first thing is null. It's passed in null, and this is supposed to magically return the first thing in the sequence.
Okay.
And then when it returns the last one, you're supposed to return false.
Oh, you actually return false. Oh, it's like super typey, like a dynamic. That makes sense.
And so when I see errors like this, that's what I think of. Is because I could totally still have bugs with my for loops. So I added for loops in the last week. And one of the things that for loops depend on is you dealing with scopes correctly. And the way that you deal with scopes correctly is you have to pop things off the stack in the right number. And there was definitely a time when I was doing that wrong. So anyways, you can see these are gone. These are gone. And then if we look through, we have a bunch more passes. Good job.
Awesome.
And these are all just passes. Oh, so here's one. This Boolean false. We can look at this. Bitwise operator and not num. Oh, yeah. So expected runtime error. Right operator must be a number.
Oh, I see. So you're not correctly validating that it's, or you're producing a different error somehow.
Correct. So I just throw a number required error containing whatever it was. I don't have the current error set up to take strings. It could trigger.
I see. Okay, that makes sense.
When I was sort of hacking it all together, I've not reached the phase where I'm trying to character for character match the error messages of Wren C.
So sometimes that's a progression, it's just not captured as a test success yet, because you're doing the correct thing, which is you've detected the actual error, and you're just not reporting it in the way that you're supposed to.
Yeah, I mean, this is close to a success. I don't know that we could count this as a success because, if you're a user and you've got number required, Boolean false.
Mm-hmm. I just mean it's like a progression, it's an improvement over the previous.
Definitely. Oh, interesting.
The math is wrong?
I don't know.
That's fascinating. Should we look at this one?
So we just pushed. Left shift. Line 5. This thing. I wonder why.
What is that number in hex? What is 114? Whatever it is, 1431. Blah blah. Oh no, I meant the other one. The expected result in hex.
This one?
Yeah.
So 8 5s and a 4?
And what did we actually get? Got extra 1. So we're not truncating. Like, I bet that's the 33rd bit.
I see.
There's like we're supposed to be throwing away this 1 somehow.
Well, I think that's very simply just, if you look at any one of these, I'm using U64. If I go back to...
Yeah, I think you're supposed to use U32 according to the C code.
Sold. That'll fix them. Anyway, so you discovered...
this is a nice part about
my weekends.
I was just gonna say this is like a good example of a good test suite, right? Like, it found an actual bug in your code, and like it explained it to you in a way that made it very, very easy to see what the problem was.
I think that the Wren authors, they wrote an okay test suite. It's designed for a language. It feels to me designed for a language that was mostly working when they started adding tests. They don't have much in the way of bring up, which is going back to the tests that I've been writing. They've been mostly bring up tests.
That also, I mean, even if they wrote it along with the engine, they may have just brought it up in a different order than you did, and so the tests that they did very early may not have.
It's very possible. I mean, we just passed a whole bunch of tests. Like, those are all just straight up passes. Good job, team.
So these are diffs. Like, when it's all red, that just means nailed it. We pass it now.
Yeah. So again, one of the things, I don't know whether I'd added this before last time or not, but so whenever I hacked the test script so that whenever it runs, instead of just printing out the output to the console, it also spits out per test output into this directory hierarchy. And so it lets me then see, and then if it doesn't have any output, it deletes whatever is there. It then lets me see changes in test results over time, which is super important. And again, I don't know if we talked about this last week, but like, you and I had this all the time in web browsers. This was...
I'm just curious about the representation. So like, now that, let's say, whatever this is, bitwise, and it's fully passing, does that mean it's an empty file in the repository?
It's a non-existent file. This file is deleted.
So when you fully pass, so it's only showing you the error diffs in some sense.
Correct. And some of this is just how the test.py happened to work. The test.py was only printing the error diffs. It wasn't even telling you about the passes. And so I chose to collect all the passes and spit them out to a file.
That makes sense.
Because I was manually doing this in the README before, and I was just like, well, once we get past whatever it was, 40 test passing, I think we had maybe 80 test passing last week, I moved to having a separate file for it. But yeah, this was great. This was a great little patch. Add bitwise. So that's RDE number 53.
I'm detecting from this output that if we did plus and times on string, we would fix 5 more tests as well.
Sure. I don't know what that even means.
Oh, find out.
Here we go. Core. So string. These are a whole bunch that we need to do too. It's like byte count and byte at, and like, these are probably not very hard. I just hadn't done them again because I didn't have the technology to.
I feel like you're at this very powerful point where you can sort of spam out a lot of the standard.
Oh, totally. Well, again, I didn't want to spam it out because I didn't want to have this file already using heavy C macros is 1,500 lines. Like, I didn't want to have a 10,000 line version of this.
Yeah, you have to get up to the technology point where it's efficient to add these things.
Okay,
string plus.
String plus. Okay. String plus. Okay. String format.
Yeah, I think it just appends them. That makes sense.
Oh. Okay. That's easy.
By the way, that thing you just did with your lips is like trademark Eric.
So like,
Yes. Like that's just the noise you make when you like all the pieces fit together in your brain and you see the answer.
my family was actually rousing me this weekend because I know I'll just like wander around and making like tugboat sounds constantly.
You know that he's having a really good day when he's just like wandering around making tugboat sounds. And just, like, everything is right with the world. Like the universe is perfect.
Oh, good times. Okay, so we need a string plus. I'm doing this in the opposite order now. String. By the way, it soothes my soul that I can use things that I otherwise associate being keywords in other languages. In Rust, num, string.
It's always awkward when you're implementing a language in that language because then everything that you have as a keyword is a keyword, and you're just like, no.
Oh, I hadn't even thought about that. I was thinking today about like, I wonder if they're writing the Rust compiler in Rust.
Oh, they totally write the Rust compiler in Rust. They love that kind of thing.
I mean,
like the Go compiler is written in Go, right? Like
that's cool, but then exactly as you so Rust. I think I was saying this to you earlier this week when we were chatting. But one of the things I enjoy about Rust is that Rust lets you use the keywords. You just have to prefix them with bang or whatever, and then you could just like freely type a Rust keyword. I've never tried it, but I've seen it in the docs. I'm asking myself, what order should I put these in? Whatever. Num plus. Okay. So we're just going to write it out for. I don't think I have any other string ones. Yeah, I don't have any other string ones. So string plus. And we need to do let a equals args 0 dot try into string.
yeah, typo duty.
You're on typo duty, you said?
Yeah.
I'm glad. So, and then this is just supposed to, so assuming we get two strings, this actually is probably not quite correct behavior. But we'll keep rolling with this because I bet it supports two string. Then we need okay num string a dot.
Do you mean value string?
Is it borrow? Yeah, value.
You're saying how do you append two strings in?
Well, they're in RCs. I'm trying to remember how to get them out. Here's a plus b. Let's see what that does. The compiler.
Yeah, I'm not sure how you append strings in Rust.
Expected RC found. Expected struct RC found. Oh, really? Okay, fine. If that works, then I'm just going to do RC new. Expected stir. Fine. Great. Great. Oh, I named it num string. Hey, the typo police. Come on. String.
That one I missed. That one is too quick for me.
There we go. Now we see how many more tests we pass. This is a good stage of the project.
This is like a very parallelizable stage of the project. You could like divide and conquer all of these standard language functions.
We used to call these victory lap patches. We still do.
So you built up all the machinery, and then like you take your car and like race it around the racetrack and run up the score.
Yep, and we totally get to run up the score here. I'm glad I saved these accidentally for the show. These are good patches. I do wish the tests were much faster on. They're totally faster on a Mac. String required. Mm-hmm. So this is probably
similar to the other situation we were looking at.
And I suspect this is the wrong behavior. I suspect we're supposed to two-string. So concatenation, we just
it's
right after two-string. So here again, we're doing it right. There's going to be a pass where I go through and I like change all these errors to require a string. And then I'll let the compiler tell me where I need to type all the strings from Wren C. And this is that we're doing scoping not quite right. But we now, what did we do? Oh, we didn't have any.
It looks like this test was sort of assuming the plus machinery was working. It was testing something else.
Let's see, we got a little further. And string plus.
To me, what you're doing here is always the goal of an engineering project. Like you're getting to the point where you can just turn the crank, and like you're just monotonically climbing this hill, and you'll get up to a point of doing this, and then you'll have to do some other like text switch or something to like be able to get to the next hill to be able to climb.
Well, and that was again my last 2 nights or whatever. I spent a lot of brain power trying to fight with, after I got my kid in bed and whatever, I was trying to fight with refactoring the world so that you could have multiple compilers. Because when we last left our heroes, you could only have one compiler ever. And
what do you need multiple compilers for?
So that you can do function parsing. So the patch that landed right before the show was the compiler now knows how to fully parse a function. It just throws away the output. Parsing compile.
Well, I mean that's something, right? You've eaten it all, and then you just disappear it.
Well, it required 2 giant patches to get there. The first was restructuring all of the. So previously, the way I was doing it was passing around this parser object everywhere, which is not what Wren C does. Wren C passes around a compiler object, and the way that happens is that when you start a parse of a file, Wren C allocates a parser on the C stack, and then also allocates a compiler on the C stack. And then as it finds itself, oh, I'm inside another function or I'm inside another scope, it'll allocate more compilers on the C stack and then chain them together with pointers.
Mm-hmm.
Totally none of this is kosher in Rust.
Rust is like, I don't understand the lifetimes that's going on here. Can you explain it to me? And you're like, not so
And
much.
so it took a lot of fighting and talking with you and just like figuring out how to write it in Rust.
Can you show us the solution that you came up with? I'm curious to see it.
It is under compilers. So if we look at parser parse token. This thing. All right, so here's struct parser, and here's struct parse context. This is what we came up with. So the parse context is the thing that's now passed around instead of the parser. And it owns the parser, of which there will only ever be one while you're parsing a file.
Mm-hmm.
And then it has a option box compiler. So option means it can be null or none, as Rust says. It has a box, which means it's on the heap instead of on the stack. And then a compiler. And this thing starts as none and then gets filled. I don't think you've even seen this. There's a
no. That's why I asked. I wanted to see it.
Push compiler. There's this push compiler scope object that look at a use of. Somebody made a comment. If he says Windows just announced that Windows 11 will support Android apps, do you think it makes Flutter's job easy to not maintain different codebase for Windows and Android for at least Windows 11? Do you think it makes Flutter's job easy to not maintain different code?
I think they're imagining that because Android applications now run on Windows, that you wouldn't want a Windows native application built in Flutter. What I think is not quite accurate. I think you might want to just have a Windows native application written in Flutter.
It's actually the native desktop story is really interesting and something we're sort of trying to figure out right now. So we've been talking with a bunch of folks, both inside Google and in the outside world, who actually do want native apps, like native Windows EXEs, and figuring out why they want them and what they're going to use them for. Like how is that different from the web, or how is it different from running the Android app on Windows, or things like that. Entertainingly enough, I was saying to you in the screen before, we think there's now at least 4 ways to run a Flutter app on Windows.
Because Windows itself is like a platform. So each of the platforms in Windows, your multi-platform thing is able to target.
Well, as Giphy alludes to, there's you can run it on the web today. You can run it on Android, I mean with the emulator, but presumably also with Windows 11. But then also you can run it Win32. We support compiling to Win32 XEs as also UWP exes. Because Windows is a platform.
Well, I think they did that intentionally. It's actually served them quite well because they've had Windows, I don't know, for however many years it's been.
Totally.
And you go through cycles of different frameworks and such over time.
But yes, you can run in a lot of ways. Okay, so I wanted to show you a usage of this. So now whenever you want to make a compiler, you don't make it directly. You call push compiler push. And we can argue about the names, because they probably need to change. But this is the current.
Yeah, it has a little bit of a stutter, but okay, yeah. So there's a scope.
And it makes this the scope object, which then you grab the context out of to pass around. It is now owning the scope reference. And then when you're done, you pop, and it returns the compiler that we were just dealing with. And
I see. Because the context has the compiler already. You can just pass it around. It's sort of like.
Yeah, the context is the thing that you pass around in the Wren Rust world.
I see. And you pop, and then it says, "Okay, here's the compiler you have been using."
Correct. And you send it to end compiler. This is a little gnarly because it has a little bit of non-local state. So this now assumes that the context is your parent, points to your parent compiler, and this is the compiler you're about to destroy. And so you write one last little thing. Again, a lot of this probably gets refactored. So I started off trying to refactor Wren C as I translated it to Rust, and I've slowly learned that's a bad idea. And now I copy the C code and I turn it into Rust code. And that's just mostly to preserve my sanity.
Because they're like subtle or complicated invariants that you haven't paged into your brain.
Correct. And I understand every line that I'm editing, but I'm not trying to rename things as much as I used to and things like that. So anyways, it pushes to this compiler and then creates the function.
Oh, I see. It rips the code and the constants off to make the function.
So tears the compiler apart. That's why you pass it in. You now own this thing.
This compiler. This is the end of this compiler. It's done.
And I think you probably rewrite this end compiler thing I think you rewrite this to not be exactly this layout. And then this is a total hack here. It's asking whether or not we're at the top level scope, basically. This was the last line of code I think I wrote in a thing that I've been fighting with for many hours and staying up too late. And so this really all it's doing is it's checking to see whether context.compiler is null or not. I just didn't know the right way to write that. And then if it is not null, we then basically emit ourselves the thing that we just compiled out into the outside world.
I see. So this is a thing that's going to take that and store that somewhere,
Yeah. So we take this function object and we store it on a constant, and then the closure is this weird combined opcode that both loads a constant and then loads a function from a constant and then wraps it in a closure. So
I see. It emits it as a constant. So it sort of throws it in the const pool. Here's all your code that you just made. Yep. And I'm going to give you a name for it that I'm going to load into this closure.
It throws it in the const pool. That's correct.
Fascinating.
And so I actually lied to you when I said that we throw it away. We don't. We take the compiled code. It's just that the other side of this, the VM side of this,
doesn't know how to call it or doesn't
know how to call it. Giphy asks, any chance on Skia migrating away from OpenGL and using Vulkan in the near future? I think it would be greatly beneficial. I don't have much idea on graphics, but I like your thoughts on Vulkan. So it turns out that already happens. Skia supports lots of backends, including Vulkan. I believe that's true. Isn't that right, Adam?
Oh yeah, for sure. And it was a big performance win when they turned on Vulkan. You're totally right.
I feel like we turned on Vulkan on Android and then we turned it back off.
Yeah, I mean that was back in the early days of Vulkan when Vulkan drivers weren't very high quality. But
I don't know what
substantially since then.
I don't know what the current state of that is, like whether we use Vulkan when it's available on Android or not.
Oh, I see. It definitely uses Vulkan on Fuchsia because there is no OpenGL on Fuchsia. There's only Vulkan.
So good news. Skia already supports Vulkan, and Flutter already supports using Skia's Vulkan backend. Let's see. So yeah, so it throws in the constant pool, and then it emits this closure, which then, if we look at the VM side, closure, giant hack.
Wait, what?
We just take the function object and, oh, what is this? This is wrong. This is wrong.
What is it trying to do?
Out of the function, the function object context. Is that where it is?
So is this operation trying to execute the function?
If this is putting it on the parent's constant objects. No, it's not. What the closure does is it just takes the function. This code is wrong, and I wonder what would happen if we fixed it. But this takes the function object that was compiled and shoved into the constant pool, and pulls it out and pushes it on the stack.
Oh, I see. It's like a load operation.
Yeah, it's basically a load. But it's pulling it from the wrong constant pool.
Because it's pulling it from its own.
Yeah, like I suspect if we just did.
Where do you normally get your constants from? Just like
that. Maybe it's self module constants. I don't know.
There must be something else in here that looks at the constant pool.
Well, there's literally the opt constant. Oh, okay, never mind. So this is the closure that we were passed into run. This is the one that we, not the one that, that's a little confusing. But yeah, some of this is that, so when I initially wrote all this VM code, I've really done so little on the VM side. When I initially wrote this VM code, I had just a Rust closure object and a Rust function object, instead of trying to make a one that's held off on the heap somewhere. Because in Wren C, everything's garbage collected. So all these obj things are all garbage collected objects.
Yeah, I noticed in your list of to-dos, like garbage collection was like the last thing on the list. It's clearly like, stop. Don't get me with the garbage collector.
Well, I am enjoying, I said this to you, I think last time we were chatting, I'm enjoying using Rust in like the way that I feel it's supposed to be used, like the safe way. I've never typed the word unsafe, even though I know that exists in the Rust keyword lexicon.
Well, I think it might be just interesting to make a version of Wren that isn't garbage collected, that's reference counted.
Yeah, I have no idea.
There's a version of that in for Java, I think, where, I mean, obviously if you write codes that have cycles, you're going to have a bad time and leak memory. But if you're careful, then you can write code that's reference counted instead of garbage collected.
Well, I see the time, and I realize we're getting towards the end of our hour. Do you want to update the viewers on your pizza?
There's no new pizza.
New pizza.
Last time we had literally I just eaten pizza that day.
I see. I have really slowed down on my bread baking. Although I think I'm going to put out the leaven for tomorrow, so I can get a roll done for Saturday's consumption. But I don't know, just habits fade, I guess.
I like the pattern on the show that like we do all this like coding, and then there's like the pizza bread conversation. It's like the closer.
I don't know. Other podcasts, they have their like they're like their object that they're going to talk about or their cocktail chatter or whatever.
Their cocktail
chatter this week.
Their call to action, like and subscribe the video and all that kind of stuff.
I have cocktail chatter. I got one of these.
What is that?
It's a Raspberry Pi.
What? That does not look at all like my Raspberry Pi.
Well, it's a Raspberry Pi in a
Oh, I see. There's the Raspberry Pi in this like fancy container with like a screen and everything.
Yeah, it was like $20 for the screen was not $20. The screen was like $70 or something. but this is the official Raspberry Pi touchscreen from the Raspberry Pi people.
That's cool. I tried to wire up the Raspberry Pi that I have to like a Nexus 7 tablet, just some like ancient Android tablet. It did not work at all. I could not get anything to show up on screen.
Well, so I got this so I could play with Flutter on it.
Oh, that makes sense.
And that's why I got the screen and stuff. And unfortunately, I haven't yet gotten it to work. Hopefully, I didn't wire it up wrong or fry it or who knows what. But that's a tomorrow problem or this weekend problem. I wanted to see what running Flutter on the Pi was like, because we have so many people using Flutter in embedded scenarios. I mean, like we talked about the Toyota people, and you obviously personally experienced it. But like, I want to feel what that's like.
Yeah, like what does it feel like to drag the scroll and all that kind of stuff?
Yeah. So, anyways, it is wonderful to see you as always. Wonderful to see all the viewers. So many of you came by tonight. It was great.
Yeah, that's great. Thanks everyone who came to the chat.
And send us some tweets. If you're getting bored of the Wren Rust, let us know. Maybe we'll do something else. But otherwise, we're gonna keep building the compiler.
See ya.
Anyways, take care.